All right, here we go. It started. We'll see. Hopefully it'll keep going. Okay, so again, what I said is we're going to take these parent functions today and we're just going to change them a little. We're going to transform them, we're going to move them, we're going to flip them, all right? And you guys should remember some of this. Hopefully it'll come back from when you did it before. All right, so graph those two functions first of all. This one is just the cubic. You guys know how to graph your x cubed. All right, so there's our nice cubic squiggle. Now, if I want the absolute value of that, how is it going to change my graph? Yeah, so everything has to be positive, right? And so instead of it coming down here on the left, it's going to have to, that not only it'll come up on the right here, but then this other side will flip up, right, this direction. And it'll kind of look like that. It'll kind of look like a parabola, but it's going to increase at a much higher rate. All right, so some of you remember how these move, and we could just graph these on our calculator quickly to investigate this. My calculator is totally gone. I don't know where it went or who borrowed it, but I will find it. Okay, so on these ones, you want to graph them on your calculator and then generalize about the movement of the function. So let's go ahead and just do this first one pretty quickly. I get x squared. We know what that graph looks like, right? But then what if I graphed it with x squared plus 1? This is kind of not. There we go. How did that graph change? So you can kind of see both of them on there. Right, the one on the bottom is the x squared, and then the one above it is x squared plus 1. So how did it move? It moved up 1, exactly. And I'm going to take a guess as to what the minus 3 one is going to do. It's going to go down 1, or down 3, sorry, right? And so when I graph that one, I see, oh, there it is. It's down 3. And what do you think the plus 2 one will do? Move up 2, and the minus 1 will just go down 1. Okay, so you get the idea here, right? So how do you graph f of x plus k? Well, plus k just means that I'm going to move it up k units, whatever that might be. Thank you. And if I graph f of x minus k, that just means I'm going to go down k. Now notice this is when the plus or minus is after the x expression, right? So it's the x squared, and then you have the plus or the minus. That's when we go up and down. What happens when I have the plus or minus in the number within the x expression in there? This is not going to be up and down. What kind of shifts are these ones going to do? Left and right. Good. And do you remember which is which? So minus 1 would be right. Yeah, it's always the opposite when it's on the inside. So you guys remember this, right? So this one would shift to the right 1. This one would shift to the left 3. This would do the left 2, and then the right 4. So the graph of f of parenthesis x plus h means that it would just go which direction? Left. Switch it. Yeah, positive would go left, h, and then the negative would go right, h. Okay, so when it's on the inside, it's the opposite. We say opposite of the inside, and then the same as the outside. Okay, so let's predict the graphs of these functions, and then we can check them if we need to. So how do you expect this one to move? That minus 4 tells us to go which way? Right 4, because it's on the inside. And then the plus 2 that's on the outside tells us to go up 2. Does it matter which one I do first? No, in this case it does not. In a little bit when we start flipping them and reflecting them, that is going to make a difference. But for now, just moving left and right and up and down, it doesn't matter which way you go. What I always like to do is I like to graph my parent function first. This is the cubic, right, because it was x cubed. Okay, so my parent function is the cubic. I like to graph it in a dotted line first. That's my parent function. Do you have to do that every single time? No. But it does help you to have that starting point. Okay? Then I'm just going to move it right 4 and up 2. Well, what do I move? I usually just move one important point. And in this case, that one important point would be my 0, 0 point. If I move that point right 4 and up 2, 1, 2, 3, 4, 1, 2, and then draw my squiggle again. Right? Knowing that that's sort of my new origin. That's sort of the new middle point, right? And then you can get, if you want to, you know that 1 to the right and 1 above would be like your 1, 1, and 1 to the left and 1 down, right? So you could do those other 2 points in there if you want to get more of a shape. But really move that one critical point just to shift the whole graph up and over. All right, let's try B. How would this guy move? Left 3, good. And then down 1, because this is off to the side. And I am a big fan of writing on there how they move. This is the radical function, so my parent function is the radical square root of x graph. And then again, what would be my critical point here that I'm going to move left 3 and down 1? Yeah, that's 0, 0 again. So I take that 0, 0 and move it left 3, down 1, and then I keep the same shape of my graph. And these don't have to be perfect. The points that I'll be looking for are that starting point, or in this case, that origin point, right? I'm looking for those points. Do you have those points correct? And then do you have like the general shape of the graph correct after that, okay? These are sketches. All right, so what's my parent function for C? What's the parent function here? Not the circle, 1 over x. Yeah, what was that one called? It had a weird name, right?
Yeah.
It was the... Yeah. It was this one. It's called the reciprocal function because it's a reciprocal, right? It's a flip. So it's called the reciprocal function, but it's the 1 over x function. So let's graph the parent function, and again, I'll use dotted lines to just graph that. Okay. This is the one that has those asymptotes, right? It's got the vertical asymptote, the horizontal asymptotes. And now how would I shift this? So what is the +2 down here going to tell me to do? Left. This is going to be left. Very good. This will be left 2 because it's with the x. And then how about the +4, which is off to the side? That's up 4. Good. So how do I move this one? Again, kind of what I'm going to move are really the asymptotes. If you kind of think of it, there was this asymptote here at 0. So now that whole asymptote is going to shift left 2. So if I shift it left 2 units, then here's my new asymptote. Okay, so you want to, on this reciprocal function, you want to shift those asymptotes, and then you can draw in the curve. And then my horizontal asymptote, which was again at 0, 0 before, I'm going to shift it up 4. 1, 2, 3, 4. So here's my new horizontal asymptote. So I've got my vertical asymptote, my horizontal asymptote. And those just give me sort of the shape for my function, right? And so then I have, this one is like 1 over and 1 up in there. And then this is 1 over and 1 down. And there's my new function. Okay? So shift your asymptotes for the reciprocal function. And then again, from that in-center point where they cross, you just do 1 up, 1 over, 1 up, 1 down, right? 1 over, 1 down, whatever, to get those 2 points in there. And then you got the shape of your new graph. Okay? Again, do you have to draw the parent function on here? No. Does it help you sometimes? Yeah, it definitely gives you a good starting point. All right, questions so far? Okay, turn the page. I'm going to stop this first video. Give me a sec.